We're going to do a series of practice problems on section 12.3, which is on the dot product. And the first question we're going to do is number 6. Number 6 gives us 2 points. I've added the labels A and B. They just gave it these coordinates. And then I've drawn a little picture. This isn't necessarily to scale or accurate, but what we want to do is take these two vectors and we want to find the cosine of the angle between them and then the actual value of the angle between them. That, of course, is going to involve using the formula for the dot product. Remember, the dot product is calculated two ways. I can calculate A dot B by taking the magnitude of A times the magnitude of B times the cosine of the angle between them. And I can also calculate it manually from their components. A1, B1 plus A2, B2 plus A3, B3. And both of these will be the dot product. Because we have all the components, we can certainly calculate this bottom value. And that's just going to be the product of each component. It's 1 times 1, 2 times 1, and 3 times 1 all added together. That's 1 plus 2 plus 3, or 6. Well, in addition, I can actually calculate the magnitude of A and B separately because I have their components. So A's magnitude is going to be 1 squared plus 2 squared plus 3 squared. That's the square root of 14. And the magnitude of B is going to be the square root of 3. So if I want the cosine of the angle solved for is just going to be the value of the dot product divided by the magnitude of A times the magnitude of B. And we have all this. So it's 6 divided by the square root of 3 times 14 is going to be 42. And that doesn't simplify, so we can just apply our calculator to it directly, and we get 0.9258. So that's the value of the cosine of the angle. And if we take the inverse cosine of that ratio, we're going to get about 22.2 degrees, which is roughly the same as 0.39 radians. So that would be the angle between vector A and B provided by 1, 2, 3 and 1, 1, 1.